In this video, we are continuing with lesson 7.1, which was kind of classifying polynomials, kind of an introduction to working with polynomials, looking at their degree, and again, just kind of dissecting the terms, like terms, things like that. So today we're going to build on that, and we're going to add and subtract polynomials. And these are expressions with polynomials. Now, really, we've already done this with the review problems I gave you, but we're just solidifying, tightening this up, and again, relating it to what we did the other day. So let's go back to what we did the other day. I asked you to simplify this expression. Again, it's an expression. It doesn't have an equal sign. And we can't solve for a missing value. All we're doing is basically doing as much math as we can. And we always start by distributing. So we would have 5x minus 30, bring down our 3x squared and our 4x. And then we want to identify our like terms, which in this case is just the 5x and the 4x. But we want to write our answer in standard form. And we do that by putting the degree of the terms decreasing in order from left to right. So that, again, means we're going to look at the exponents. This term is a 3x squared, so that is our highest degree term. When we add our x's, 5x plus 4x is 9x, and then our constant is minus 30. If we were to classify this, this is a trinomial, and its degree is 2, because that is the highest degree that we see in one of the terms. So now we're going to look at what polynomial addition and subtraction looks like. You can actually set up the problems two different ways. And what I did was for the two examples I'm about to show you, I set the same problem up horizontally and vertically. So this is the horizontal setup here, and this is the vertical setup here. Horizontal is kind of traditional. It's sort of what we've seen, but the vertical setup can be really nice, especially when you're trying to line up who your like terms are. For the first example, we are going to be adding two polynomials. And as you notice, this is in parentheses and so is this. But because we have an addition sign in between and addition is commutative, we really don't need the parentheses. We just put the parentheses there to show that we have one polynomial and we're adding it to a completely second, so we have one trinomial and we're adding it to a completely second trinomial. But it's basically what we did in the warm-up. We identify our like terms, add them together, and then make sure it's written in standard form. 8x squared plus negative 5x squared is 3x squared. Negative 7x plus positive 1x, negative 6x. 4 plus negative 17 or minus 17 is negative 13. That's the answer. Here it is in standard form, ready to go. The vertical setup is kind of nice, I think, because it really just aligns all of those like terms for you. And I think for some kids, it really identifies the sign of the terms better. You're able to be like, okay, this is like 8x minus 5x, or excuse me, 8x squared minus 5x squared. That's 3x squareds. Negative 7 plus 1, negative 6. X. And then the 4 minus 17, negative 13. I mean, we're going to get the same answer either way, but sometimes the vertical alignment just makes things easier to understand. The second example, this is one where you just have to be careful no matter what you're doing because you're subtracting. And so when we have this, and I want to kind of look at both examples at the same time. When we have 12g squared minus 8g plus 9, that's our first trinomial. And from that, we are subtracting this second trinomial. We are subtracting 3g squared minus 17. And that's distributing a negative. And we've seen this before, but I'm hoping this makes a lot of sense, seeing it again and kind of talking about it this way. So we are subtracting everything inside this second set of parentheses, and that's why the signs both switch. So right now it's a positive 3g squared, but when we distribute the negative, it becomes negative 3g squared. And then with the 17, it's a negative 17, but when we minus a negative, or think about distributing that, that's when the sign changes, becomes its opposite, and we have a positive 17. And then my first trinomial again, 12g squared plus 8g minus 9. And combining my like terms, I would get 9g squareds. I don't have a like term with the 8g, which is okay, just comes in the middle. And then negative 9 plus 17 is positive 8. So that's our simplified answer written in standard form. In this second arrangement here, in this vertical arrangement, again, notice that you have the minus sign in front. So I think you have to be a little bit more intentional here. Sometimes what I've seen students do is actually change this to a plus sign and then go ahead and switch all the signs in the parentheses. So this becomes a negative, and this becomes, as you can see, I took that negative 17 and I kind of turned it into a plus sign. And that might make things just maybe a little bit easier for you to see. Either way, you just have to be super careful when you're subtracting polynomials, because in that second polynomial, you switch the sign of every term because of the subtraction. As you notice, I don't have a g term here. I don't have a linear term, and so I'm just going to add like normal, but I kind of leave a space. I purposely lined up my constant with my other constant, and so that's something you'll see in this sort of notation as well. Ultimately, 12g squareds minus 3g squareds is 9g squareds. Bring down our 8g because it's like adding it to 0, and then our positive 8. One more other application when we're working with these polynomials is finding perimeter, because perimeter is where we add up all the sides. And so here is just a quick little problem for us to look at. The lengths of the sides of a triangle to the right are shown. Write an expression to represent the perimeter of a triangle. So perimeter is just anytime we just want to add up all the sides. Certain shapes actually have formulas like squares and rectangles, but with a triangle, we just add them up. So our three sides are 12x minus 5, and we can put this parentheses if we want, 11x squared minus 7x, and 7x squared plus 9. So that's the expression to represent the perimeter of the triangle. It doesn't equal anything that we know right now. We're just writing an expression. Now we want to simplify. Again, because addition is commutative, it's like we don't need these parentheses anymore because we're thinking of this as addition. And then we can go ahead. Technically, it's addition is commutative and associative, so also would be important to note. My 11x squared, I like to start again with my highest degree terms because I'm going to be writing it in standard form. So I would have 18x squareds. I've got a 12x and a negative 7x, so that's positive 5x. And then I have a negative 5 and a positive 9, so that's positive 4. And then I would write centimeters. That is something I want you to make sure you know. We want to put units down. I guess technically I should put the centimeters up on that one as well. So there we have it. Those are some looking at some problems with adding and subtracting polynomials, and just taking a look at a quick application of this.